challenge after every practice. This challenge consists of everyone standing in a line on our team, kicking the ball and trying to hit the crossbar. The winners don't really win anything, but it's still fun. For this project, Raquel and I decided to examine the physics in the crossbar challenge, and after her first shot, she hit the crossbar. The question we want to ask now is if Raquel is standing 22 meters away from the goal, and if the crossbar is 2.44 meters from the ground, at what launch angle and initial velocity does the ball need to leave her foot in order for it to hit the crossbar 2.3 seconds after contact?
Step 1 is to draw a picture. As you can see, the goal is 2.44 meters high, and I am 22 meters from the goal.
Step 2 is to determine the initial velocity in the x direction. If we know that the initial position of the ball is 0 meters and the crossbar is 22 meters away, and the change in time from the point the ball leaves the ground to hit the crossbar is 2.3 seconds, we can plug this information into the equation x final equals x initial plus the initial velocity in the x direction times the change in t. And we get that the initial velocity in the x direction is 9.57 meters per second. Step 3 is to determine the initial velocity in the y direction. If we know that the initial position of the ball on the y-axis is 0 and the final position is 2.44 meters and the change in time is 2.3 seconds, then we can plug this information into the equation y final equals y initial plus the initial velocity in the y direction times the change in t minus 1/2 times the acceleration due to gravity times the change in t squared. And from this equation, we get the velocity in the y direction initially equals 12.33 meters per second.
Step 4 is to determine the initial velocity. We can do this because we now know both the x and y components of initial velocity. Using the Pythagorean theorem and the fact that the hypotenuse of the velocity components is the initial velocity, we determine that v initial is 15.61 meters per second.
Step 5 is to determine the launch angle. We use the equation Vx initial equals V initial cosine theta. We know that the initial velocity in the x direction is 9.57 and the initial velocity is 15.61. So we can plug these values into the equation to get that theta is 52.19 degrees.
The next question we want to answer is, did the ball hit the crossbar before or after its maximum height? We know that when the vertical velocity is 0, the ball is at its maximum height.
So we use the equation Vy final equals Vy initial minus g times change in t, and we get that the change in time is 1.26 seconds. Because 1.26 seconds is less than 2.3 seconds, we know that the ball hits the crossbar after reaching its maximum height.
Yo, man, it's going down. We gon' let you know how we play. Come, hey.